Good day and welcome to the latest in our series of webinars that we at AkzoNobel are putting together in April and May of 2020. Today we will be covering a webinar on reducing systems complexity for modular construction, and this will be particularly with paints and coatings. My name is Suman Bhatt, and I work as a sub-segment manager for AkzoNobel in the marine and protective coatings business. In today's webinar, we will be covering a quick background to modular construction and why it's been increasing in its popularity particularly for oil and gas. We'll cover specification complexity in coating systems for modular projects. We'll go on to discuss AkzoNobel's experience in modular construction, again focusing on the oil and gas industry, and then go on to discuss some of our solutions for the modular construction industry. And then we'll, as always, end with a quick summary of what we've discussed. So what is modular construction? Modular construction involves prefabricating equipment and systems into modules at an off-site fabrication yard. Once constructed, these modules are delivered to the final site location where they can be installed and commissioned. The oil and gas industry first started experimenting with modular construction in the 1970s, and at that time on a fairly small scale. The picture on the right of the screen is of an offshore platform constructed in modular fashion in the late 1970s, operating in the Ras Burdan field in Egypt. The modular construction boom really began in the 1990s at the beginning with the offshore industry. In the 2000s, it began being used in onshore processing facilities such as LNG liquefaction plants. And more recently, we've seen its popularity rising in building refineries and petrochemical plants as well. Here we'll take a quick look at the pros and cons of modular construction. On the plus side, modular construction results in more reliable access and efficient use of skilled manpower. This is particularly critical in the oil and gas industry, where the pool of experienced tradespeople, such as welders and electricians, can be limited. With a stick-built approach, which is the other option to modular construction, securing skilled workcraft can often inflate costs due to the need to provide travel allowances and housing accommodations on site. In many instances, an off-site module fabrication facility can be selected in a region or in a country where labor supply and demand is more balanced, and hence the cost of skilled manpower is lower. Shorter development cycles. Modularized construction can reduce a project's development schedule, and it does so in a number of different ways. First, by assembling modules using prefabricated parts off-site in a designated facility, the chance of running into delays caused by weather or other environmentally related factors on-site is minimized. Second, building offsite also affords operators the advantage of being able to perform work on multiple areas of a facility simultaneously. This isn't always possible when using the traditional stick-built approach, as the amount of workable space on site is often limited. And third, by performing work offsite, operators can remove certain activities from the schedule's critical path and reduce the chance of trickle-down delays. So all in all, it results in shorter development schedules. There's an improved quality as well. Prefabricating modules Also provides advantages with regard to quality control and assurance. Prefabrication allows for testing of modules at the fabrication yard, including QA and QC of painting work. In doing so, any problems or defects can be identified and quickly resolved in the fabrication yard, which significantly reduces costs during installation and commissioning. There's an increased safety because prefabricating facility components reduces the number of individuals required to be working on site, which obviously increases the amount of safety related to a project. And all of the above factors finally leads to an overall reduction in the project cost, and it's by a significant amount. On the other hand, there are a few drawbacks with modularization. Firstly, it involves a considerable amount of upfront planning, and this is to avoid engineering delays. With so many moving parts and a number of activities performed by multiple vendors, multiple people, coordination of engineering as well as construction activities becomes very complex. Material selection becomes more complicated and cumbersome. Not only does the operating environment of the final location need to be considered in selecting materials, but also the construction locations and delivery route and method. This is especially so with coatings, as we'll discover in the later part of this webinar. And of course, modular construction involves moving thousands of tons of equipment and steel, sometimes halfway around the world, which can be a logistical nightmare. These shortcomings, important as they are, can to a large extent be mitigated by making smart choices during engineering and design. And in today's webinar, we will cover how we think certain choices in coatings or paint specifications for modular construction projects can reduce the impact of some of these drawbacks just discussed. In this section, we will talk about the aspects of modular construction that lead to coating system specification complexity. As we discussed in the previous section, one significant downside of modular construction is the increase in engineering complexity. A significant component of this is coating system specification complexity. This is due to the fact that modern modular projects involve multiple engineering locations and multiple construction sites. They typically also involve complex supply chains with potentially hundreds of vendors, and all of this necessitates close monitoring and control. All of this increased complexity leads to, of course, increased cost, and this is due to multiple factors. First, an increase in complexity increases the chance of human error. Second, there is a need for greater inspection and monitoring, and you need to have teams to do this in all key locations during construction and installation. Third, a small error in engineering at the beginning of the project can have a ripple effect down the line during construction, and due to the complex nature of these projects, this can have a massive impact. In the next few slides, we will delve further into the source of coating system complexity and then think about how this might be mitigated by designing the right coating specification. The scale and scope of oil and gas projects has increased tremendously in recent decades, and that to an extent has led to the increase in coating system specification complexity. A typical project can involve dozens or even hundreds of modules, like the one that you see in the bottom center of your screen, thousands of valves, vessels, pipes, and other equipment. all fabricated in different locations. Adding to this complexity is the fact that coating systems also vary based on type of service or operation, the substrate they're applied on, and the operating temperature of the equipment, and whether there's any insulation required. The pictures at the bottom of the slide show some of the different operating conditions that can exist. On the left, we have an FPSO hull, and that is exposed to immersed or splash zone sort of conditions. You've got structural steel in the process modules that you see in the center. Then, of course, we've got piping and vessels which can be subject to a variety of operating temperatures. And all that leads to specifications that look like this. I'm sure a lot of you would have been involved in a project that had a coating specification that looked something like this. Given the complexity of end users that we talked about earlier, it is little wonder that we've ended up with 7 or 8 different types of coating systems to be applied on structural steel and piping alone in order to deal with the variation in operating temperature, substrates, insulation requirements, and different exposure conditions. And this complexity inevitably leads to increased cost and in some cases poor quality. The result, it's a paint shop manager's nightmare. And as one of our customers described it, in a single month, I will use 40 different coatings from 6 different manufacturers. It's a nightmare. Those were their words. Complexity in specification can also lead to errors during construction. Bulk supplied items such as valves sometimes arrive at the fabrication site with the incorrect coating for the final operating environment, which inevitably then leads to costly rework. So the question is there a better way to do things? Given the complexity in construction process and the operating environment, can we design coating specifications that are simpler, yet give us the flexibility in end use and the durability and performance required? No prizes for guessing the answer there. Before we get to what we believe could be the solution, I'll take you through a brief introduction on how we arrived at this from our experience in modular construction. Many of you will be familiar with AkzoNobel or International Paint, but for those of you who aren't, here's a quick introduction to our marine and protective coatings business. We were founded as International Paint in 1881, and we've hence become part of the AkzoNobel group of companies. Initially founded to serve the marine industry in the UK, we've got decades of experience in the oil and gas industry. We've been suppliers to some of the most iconic projects in the industry, both offshore and onshore. Been the global leaders in passive fire protection with our epoxy fire protection range, which goes under the brand name Chartec. And as I'll describe in the next few slides, we have unparalleled experience in global mega projects, which all employ modular construction. The first of what we describe as mega projects was Gorgon LNG, with nearly 100 topsides modules, 230 tons of piping and subsea equipment, and a capex of $54 billion. It was a project the likes of which the oil and gas industry had never seen before. We were chosen as the coating supplier for all the major locations where the project was constructed. And as I said, that was our first experience in what we would truly describe as a global mega project. As mentioned in the previous slide, the Gorgon project was at a global scale and scope that we had never experienced before in oil and gas. The key front-end engineering work took place in London and in Houston. There was fabrication and painting across at least 8 different locations in Europe and in Asia, which covered modules, pipes, pipe racks, valves, and vessels. And of course, those 100 modules and 230,000 tons of piping all came together in the remote Barrow Island in Northwest Australia. This gives you a sense for the complexity involved, and this really has become the norm in recent years in modular built projects, especially in LNG. Another similar project, also in Northwest Australia, was Ichthys. And with this one, there was an additional complexity of having an offshore processing platform and FPSO added to the onshore processing facilities. Like Gorgon, it involved a massive amount of piping. In this case, it was 889 kilometers of subsea piping. In addition, it was built with a 40-year design life. And like Gorgon, AkzoNobel International Paint was the preferred supplier in all locations. The third and final example of modular built mega project that I'll use in today's webinar is the Yamal LNG project. And I've used this example to highlight the complexity in extreme environmental conditions that we sometimes face on these projects. The 800,000 tons of modules that were installed in Sabeta, which is located in the Yamal Peninsula of Russia, where the winter temperatures often go below minus 40 degrees centigrade or 40 below freezing. Added to that is the remoteness of the site, which makes it a logistical nightmare. And you can imagine how difficult it is to set up a crew to do site work in a project such as this. So our involvement in these diverse and challenging projects has given us some key insights into coating specification design. First is that a global supply chain is an absolute must. Any coating supplier involved in these types of projects must be able to deliver paint to all the fabrication and painting locations, and of course to the site, which is often in remote locations. Many of these projects come with stringent and unique design standards, as well as environmental and regulatory challenges, all of which the coating supplier needs to be capable of catering to. So the key lessons that we've learned are that first, a traditional three-coat scheme or three-coat system for atmospheric service, which comprises of a zinc-rich primer, an epoxy intermediate, and a polyurethane top coat, are a drain on productivity and can be a bottleneck on the critical path of the project. We'll see an example of why this is later in the webinar. Second is that phenolic epoxies, which are often specified for insulated pipes and vessels, do not perform well in atmospheric service because they are not designed for that use. The trouble is with modular constructed projects, especially the large ones, is that piping and vessels that have been applied with a phenolic epoxy often lie in the fabrication yard for 2 or 3 years before they are shipped to the final location for installation. And during this period, they often suffer premature failure. Finally, a common primer for the anti-corrosive and pacifier protection systems is a must, not only to promote productivity, but also to ensure quality. We now come to our recommendations for coating system design in order to reduce specification complexity, and this revolves around our universal coatings concept. The evolution of our universal concept goes back to the 1980s when Intershield 300 was launched. It was initially intended as a universal primer for ships, which could protect the hull, ballast tanks, and topsides, accommodation, and decks, all using the same product. In the 1990s, that concept was adopted by the offshore oil and gas industry, primarily on FPSOs, which at that time were just ship hulls with some processing modules on top. And this is where Intershield 300 really started coming into its own. We then extended that same concept in the early and mid 2000s to modular build projects, such as some of the examples that you've seen previously, like Ichthys and Yamal, where Intershield 300 was used as a universal primer for both the anti-corrosive and the pacifier protection systems. Thus, we were able to break a long-held myth that zinc-rich primers were necessary to achieve long-term corrosion protection in harsh environments. Next, in 2013, we launched the universal pipe coating concept with Interbond 2340 UPC, and more on that in the coming slides. And last year, we've taken the universal concept a step further with the launch of Intershield 4000 USP, which is a primer for structural steel that replaces or aims to replace zinc-rich primers and brings significant productivity benefits. And we'll hear about a bit more detail about each of these concepts in the next few slides. We start with a deeper look into universal primers such as Intershield 300 and Interguard 7500. Now, these products can be used in multiple end uses such as atmospheric exposure, immersion, and as a primer under pacifier protection. The key attribute is that they provide as good, if not better, anti-corrosive protection than the traditional products that they replaced, such as zinc-rich primers for atmospheric end use. The graphic on this slide shows a comparison of the complexity of the traditional specification approach, which you can see with the slightly blue background, where 6 or 7 different products were needed to do the job just for ambient temperature exposure. This is in contrast to the universal primer approach, and that's what you see with the slightly pink background here. And this is where a single primer is used, a primer such as Intershield 300 or Interguard 7500. And all you need is a polyurethane top coat over it for atmospheric exposure or UV exposure, or in the case of a fire protection system, then you apply the fire protection product directly over the universal primer. So this significantly reduces the number of products that you need to protect both structural steel as well as immersed steel. In addition to the complexity reduction, which obviously reduces inventory cost and potential for human errors, there is also a massive productivity benefit in moving to this universal approach. As you can see on the graphic in this slide, using Intershield 300 or Interguard 7500 can save huge amounts of time in the paint shop, which is often a bottleneck in the project. As shown here, Interguard 7500 or Intershield 300 can be overcoated in just 4 hours compared to a typical zinc-rich epoxy that takes 8 hours at an ambient temperature of 5 degrees C. And that means you can get through 2 coats in a shift with the universal primer rather than just one if you're using a zinc-rich primer. The effect is magnified for fireproofed areas, and this is because the traditional approach would require an application of a tie coat, meaning that you would need more than 24 hours between the primer application and the fireproofing. In contrast, with a product such as Interguard 7500 or Intershield 300, the fireproofing can take place in the same shift as the primer application. And that saves a massive amount of time especially in modular construction. Next, we come to the concept of universal pipe coatings. The name really says it all, and this is where we just have one or possibly two products which are specified on all pipes and vessels, covering the entire range of operating temperatures, insulated or atmospheric service, and covering different substrate materials. In our case, we have Interbond 2340, which can handle temperatures from cryogenic up to 230 degrees C or 446 Fahrenheit. Importantly here, it also shows excellent performance at ambient temperatures in atmospheric exposure. And this is something that phenolic epoxies fall short of. Interbond 1202 UPC takes it a step further, and it protects steel from cryogenic all the way to 650 centigrade or 1202 Fahrenheit, which is where the name 1202 UPC comes from. Both these products are compatible with a wide range of top coats in case there is a need for color coding and things like that. So using the UPC products such as Interbond 1202 UPC, we can reduce the number of products used on high heat specifications down from 6 or 7 down to just 1 or possibly 2. With the 2340 UPC, similarly, we are able to replace multiple systems such as phenolic epoxies, traditional 3-coat zinc epoxy polyurethane, or even in some cases zinc silicates and aluminium, silicone aluminiums down to just the Interbond 2340 UPC. Importantly, with this product, it also delivers fast cure and cold temperature cure capabilities, and that can be invaluable in modular construction projects. As you can see from the table in this slide, there is a significant time saving to be had by switching to Interbond 2340 UPC compared to a phenolic epoxy. Another important advantage is that Interbond 2340 UPC shows excellent corrosion protection at ambient conditions, which is something that phenolic epoxies fall short of. This could be vitally important in large modular construction projects where piping equipment can lie around in the fabrication yard for months or even years before it is shipped to the site and installed. We've seen multiple cases where the phenolic epoxies have started to break down even before installation, and this obviously causes a huge amount of not only costly rework but potential delays to the project. If you would like to know more about universal pipe coatings and Interbond 2340 UPC, please do check out the webinar that my colleague Ian Fletcher has posted covering this subject. It is also available through our e-learning portal. Our final pillar of universal protection is the universal primer for structural steel. We have recently launched the Intershield 4000 USP, which is our universal system primer based on alkylated amine epoxy resin technology, reinforced with passivation pigments. This is a breakthrough innovation through which we are now able to replace traditional zinc-rich primers for structural steel without compromising on durability. This leads to significant cost and time savings because Intershield 4000 USP is significantly faster curing than zinc-rich primers, and it can also be applied down to -5°C. Importantly, it does not need a tie coat before application of a fire protection scheme, and this can lead to a significant amount of complexity reduction as well. An added benefit of this product is that it is very easy to apply and much more forgiving compared to zinc primers. I have previously recorded a webinar on Intershield 4000 USP. So for those of you who are looking for more information on this product, please do have a look through that webinar, which is also available on the AkzoNobel e-learnings portal. With that, we are nearly at the end of today's webinar. I will now end with a quick summary of what we've covered today. So the key lessons that we've learned from past modular construction projects where we've been involved in for coating specifications is that specification simplicity is an absolute must. So it increases productivity, improves quality, and reduces cost. Productivity can be absolutely paramount in these large modular construction projects because a small delay anywhere along the construction chain can lead to huge impacts in installation and commissioning. Robustness in performance must consider the construction phase as well as the operating phase that a product is subjected to. And a good example of this is phenolic epoxies, which may be robust enough for the actual operations that they're meant for, which typically is high heat insulated service. But they are not robust enough to handle the construction process in a typical modular construction project where piping equipment is exposed to the elements for a year or 2 years before it's actually shipped to the site. Universal primers have transformed corrosion protection and universal primers, AkzoNobel have pioneered the use of universal primers with the Intershield 300, and they act as a common primer for immersed, atmospheric, and fireproof steel. They're faster and easier to apply and more robust in performance compared to traditional coating systems such as the zinc epoxy polyurethane 3-coat system. Finally, universal pipe coating products have revolutionized high heat specifications. They enable a single product to be specified covering a wide range of pipe and vessel protection requirements. They have excellent protection, corrosion protection, both at ambient as well as at high temperature. And they enable both productivity and performance benefits in modular construction, both of which lead to huge cost savings. That's all we have for today's webinar on modular construction and reducing systems complexity. Thank you all for listening, and I hope you found this webinar useful to you. Thank you.